Hi everyone, welcome back to my video. I am Dr. Hang Ding from Indiana University South Bend, and I have recorded several videos about introduction to Java and also control structures in Java. In this video, we will talk about a new topic in Java programming, which is methods in Java. There will be two videos about methods in Java, and this video will cover the first part. In the first part of methods in Java, I will cover 4 sections. The first section is an introduction to methods, explaining why we need methods in Java. The second section will cover static methods, static variables, and in particular, we will cover the class math, which is a predefined class in Java. And in the third section, I will show you how to write a methods by yourself. And in the fourth section, we will discuss the methods call stacks, just to show you how it handles the methods calls. Let's begin with the question, why are methods important in Java programming? We know that the best way to develop and maintain a large program is to construct it from small, simple pieces. This technique is known as divide and conquer. Methods or functions support the divide and conquer techniques. They facilitate the design, implementation, operation, and maintenance of large programs. You typically write Java programs by combining new methods and classes that you write with predefined methods and classes in the Java API. Note that methods in Java are called member functions in C, C++, which is another language. For any method, the statements in the method body are written only once and hidden from other methods, but they can be reused from several locations in a program. Using existing methods as building blocks to create new programs is called software reusability. To promote software reusability, every method should be limited to performing a single well-defined task, and the name of the method should express that task efficiently. A method that performs one task is also easier to test and debug than one that performs many tasks. If you cannot choose a concise name that expresses a method's task, your method may be attempting to perform too many tasks and should be broken into smaller ones. Dividing program into meaningful methods makes the program easier to debug and maintain. When you write a method, you describe how the method performs its designated task, but a method won't perform its task until it is called or invoked. Only when a method is called that the code in the method body is reused or used. When the called method completes its task, it returns control and possibly a result to the caller. This is similar to the hierarchical form of management. So in that form, a boss, which is a caller, asks a worker, which is the called method, to perform a task and report back or return the results after completing the task to the boss. The boss method does not know how the worker method performs its designated task. The worker may also call other workers' methods unbeknown to the boss. This hiding this hiding of implementation details promotes good software engineering. Methods can be classified into two general types based on their return types. One is void method and one is value returning method. A void method simply performs a task and terminates. A value returning method does not only perform a task but also sends a value back to the caller. The methods calls of these two types of methods are also used in different ways. In particular, a method call of a void method must be a standalone statement, as in this example. This is a call to the method println on the system.out object, which only prints out a line of text and does not return any value. So we place this method call alone and place a semicolon at the end. For a value returning method, a method call should be embedded in an expression because the method call itself is an expression. For example, the method call to the POW method of the math class can be embedded in any expression that accepts a double value because this method returns a double value. Similarly, the method call to the nextInt method of a scanner object can be embedded in any expression where an integer value is expected, for example, assigning it to an int variable. In Java, methods are defined as members of a class and are normally called on specific objects of that class. Because the tasks performed by the method usually depend on the content of the object. But sometimes a method performs a task that does not depend on the contents of any object. Such a method can be defined as a static method or class method. Recall that static methods, such as the POW method of the math class, can be called on a class rather than an object. A static method is declared with the keyword static, as in the method main, and applies to the class in which it is declared. By the way, why is method main always declared static? This is because the main method is the first method to be invoked when your Java program executes. There's no prior method to create an object on which the method main is called. So declaring main as static allows the Java virtual machine to invoke the method main without having to create an object of the class you specify. We will now explore the math class, of which all methods are static. The math class is part of the java.lang package, which is imported implicitly by the compiler. So it's not necessary to import math class to use its methods. Recall that we have used one method from the math class, which is POW, to calculate the compound interest. You can view the descriptions of all methods in the math class at this link with the domain docs.oracle.com. This link has the list that shows the method in alphabetical order. So the first one in the list is the method ABS, which takes a number as its only argument and returns the absolute value of the argument. Note that there are several versions of the ABS method depending on the types of its argument. The return type of the method F is the same as the type of its argument. In particular, if the argument has type double, then its return type is also double. And if the argument is of type float, then its return type is also a float. And so if the argument is an integer, then the return type is also an integer. And if the argument is a long number, then the return type is also a long number. So there are 4 versions of methods F corresponding to 4 primitive types for numbers. Here are a few other methods in the math class. Method EXP, which is short for exponent, takes one double value x as argument and returns the Euler's numbers e raised to the power of x. So EXP of 1.0 returns the Euler's number e, which is approximately 2.718. Method log also takes one double value x as argument and returns the natural logarithm of x. Since the base of the natural logarithm is the Euler's number e, taking logs of EXP of x returns the value of x. The next 2 methods are the max and the min methods. The max method returns the greater of its 2 arguments, and the min method returns the smaller of its 2 arguments. Both arguments of each of the max and the min methods must be of the same primitive numeric type. In particular, like the F method, there are 4 versions of max and 4 versions of min, corresponding to 4 possible types of their arguments. The method route takes a float value or a double value as argument. It then returns the closest long value to the double argument and the closest int value to the float argument. For example, root of 2.5 is 3. Root of minus 2.5 is minus 2. Root of minus 2.15 is minus 2. And root of 2.15 is 2. The last method is SQRT, which takes a double value x as argument and returns the correctly rounded positive square root of x. So to calculate the square root of x, we can use the power method or the SQRT method from the math class. Note that a Java class can also define or declare variables that represent common attributes of its objects. Variables of a class are sometimes called fields. In addition to static methods, math class also contains static fields, including 2 final variables or named constants, pi and e. The constant pi has the value equal to the ratio of a circle's circumference to its diameter, which is 3.14, etc. Okay. The constant e is the base value for the natural logarithms. which are computed by the static methods log of the math class. Recall that the final modifiers indicates that these variables pi and e are constants, that is, their values cannot change after they are initialized. These constants are also declared with modifiers public and static. The modifier public allows you to use these fields in your own classes. The modifier static allows this field to be accessed via the class name math and a dot separator. So you write math.pi to access the constant pi of the math class, and you write math.e to access the constant e of the math class. Now I'm going to show you how to declare or define a method by yourself. A method is a collection of statements that are grouped together to perform a task. Defining a method requiring specifying method's header and method body, similar to defining the method's main. Method headers consist of modifiers, return type, the method name, and the formal parameter list. The method body is delimited by the left and the right braces and contains statements that perform the method's task. Let's consider a complete Java program that shows an example of defining another method beside the method main. This program has only one class named maximum feeder. So it is stored in the file maximumFeeder.java. Class maximum feeder has two methods main and methods maximum. The method main prompts the user to input 3 floating point values and reads 3 floating point values from the keyboard into 3 variables of type double and named number 1, number 2, and number 3. Then the method main calls the method maximum, passing number 1, number 2, number 3 as actual arguments. Method maximum returns a value which is then assigned to variable result in method main. Finally, the method main displays the value of variable result. Note that the method main only calls method maximum. It does not define method maximum. The definition of the method maximum is placed in the same class maximum feeder as the method main. We typically place non-main methods after the main method. This is the definition of the method maximum in lines from 28 to 41. Line 28 contains the method header of the method maximum, and lines from 29 to 41 contains the method body of the method maximum. The body indicates that the method maximum determines and returns the largest of 3 double values x, y, z, which are specified in the parameter list in the method header. The general syntax of method header starts with modifiers, then return type, then the method name, and finally the formal parameter list in parentheses. The formal parameters are separated by the comma if there are more than one parameters. The method headers of both method main and method maximum in the maximum finder class use two modifiers, public and static. The public modifier allows the method to be called by methods of other classes, so a public method is available to the public. The static modifier makes the method static. For now, we begin every method declaration with the modifiers public and static. You will learn about non-public and non-static methods in later course in computer programming. The return type of the method specifies the type of data a method returns to the calling method after performing its task. When we say a method returns to the calling method, that means the method gives back to its caller. In some cases, you will define methods that perform a task but will not return any information, such as method main. Such methods use the return type void. A method name can be any valid identifier. However, to make the program easier to read and maintain, we adopt the naming convention in which method names begin with an initial lowercase letter, similar to variable names, such as display grade. So here it starts with a lowercase letter in each word, and for each subsequent word it starts with an uppercase letter. Also in our naming convention, class names begin with an initial uppercase letter. Formal parameters of a method are placeholders representing additional information that the method needs to complete its task. Formal parameters allow the method to do the same task but in different settings. For example, having three parameters x, y, z allows method maximum to find the largest value of any three double variables instead of three specific double variables. Each parameter must specify a type and an identifier, which is the parameter name. Note that declaring method parameters of the same type as in double x, y, z instead of double x, double y, double z is a syntax error. A type is required for each parameter in the parameter list. A method's formal parameters are considered to be local variables of that method and can be used only in that method's body. The method body follows the method header and contains statements that perform the task of the method. A value returning method's body must have a return statement which starts with the keyword return and followed by a returning expression. The returning expression must have a value matching the method's return type. For example, in the maximum method, which has return type double, the last statement in the method body is return maximum value, semicolon. where maximum value is a variable of time double. Note that the entire body of the maximum method could also be rewritten as a single return statement with two calls to the method max in the math class as follows. The outer call to max specify the arguments x, and the result of the inner calls to math.max with the two arguments y and z. So basically it apply the math.max to find the maximum value between y and z, and then pass that as the second argument to the outer call of max, whose first argument is x. The return statement returns the control and also a value in case of a value returning method to the point in the program from which the method was called. Note that a voice method's body may also have return statements but without a returning expression. For example, here is a void method that displays a grade. It takes a score, which is a double value, as parameters, and so it will display letter grade A, B, C, D, or F. And here we want the score to be larger than or equal to 0 in order to convert it to letter grades. But if the score is less than 0, so we don't want to do anything. So therefore, we can add the if statement that checks if score is less than 0, then return. So in this case, it just get out of the method immediately. And there's no need to have a return statement at the end of the void method. There are a couple of common syntax errors in defining methods that I like to mention. The first one is declaring or defining a method outside the body of a class declaration or inside the body of another method. By the way, note that some textbook authors use the term declaring a method while others use the term defining a method. These two terms mean the same thing in Java, although they may mean different things in other languages like C and C++. The second common error is redeclaring a parameter as a local variable in the method body. For example, if the identifier n is already used as a formal parameter in the method header, then declaring a variable n inside the method body will result in a syntax error. This is because every parameter is also considered a local variable of that method, so you cannot redeclare it inside the method. When you define a method, you write the code performing what the method is to do, but the code of the method won't execute until the method is called. And except for method main, every method must be called explicitly by another method to tell it to execute. To call a method of a different class, you have to specify the class name or an object name depending on whether the called method is a static method or not. If the called method is not static, then use the syntax that starts with the object name and then the dot and then the method name followed by arguments in parentheses. For example, to call the method next double of the scanner class, you have to create a scanner object, for example input, and then use input dot next double expression. If the count method of a different class is static, then use the class name and the dot before the method name and arguments, as in this syntax. We had used this syntax to call the method pow of the math class before. In many of our examples before, we already called a method of a different class, which is in the Java API. Now that you can define several methods in your own class, you can have one of your methods call another method of the same class in your program. To call a method of the same class, you use the method name by itself, as in this statement in the main method of the class maximum finder in our example before. Here you only specify the name of the called method, which is maximum, followed by the list of arguments. When a method is called, the caller transfers control to the called method. For example, when the call to the maxInt method in the method main executes, the main method, which is the caller, transfers control to the method's maxInt. The code in the body of the maxInt method will then execute. The called method returns control back to the caller when its return statement is executed or its method ending a brace is reached. In this example, the called method maxInt is a value returning method because its return type is not void. So it returns control back to method main when the return statement in the method maxInt executes. When you make a method call, you have to provide actual arguments or just arguments, which are values passed to the method's parameters. Recall that parameters or formal parameters are placeholders in the method definition, more specifically in the method header. The actual arguments are the actual values put in those placeholders when the method is called. The arguments in a method call may be a constant or variables or an expression. For example, in this method call of the method maxInt, there are three arguments. The first one is variable num. The second one is constant integer 20. And the last one is the expression 2 minus num. In most cases, the number, the order, and types of arguments in a method call must match the formal parameters in the method header. Otherwise, a syntax error will occur. For example, here a method maxInt has three parameters. All of them are of type int. So in a method call to method maxInt, there must be three arguments, each of which must have an int value or can be converted to an int value. Java manages the method calls by using a data structure known as method call stack. The stack data structure is a list of items operating similarly to a pile of dishes. When a dish is placed on the pile, it's normally placed at the top. This is referred to as pushing onto the stack. When a dish is removed from the pile, it's normally removed also from the top, which is referred to as popping off the stack. In other words, items are added or removed from the stack in the last in, first out order. That is, the last item pushed onto the stack is the first item popped from the stack. Each entry or item in the method call stack is an activation record, which is also referred to as a stack frame. When a method call is made, the activation method of that method call is created and pushed onto the stack. When a method returns to its caller, the activation method of the method call is popped off the stack. As an example, consider a program with a single class that has two methods, main and maxInt. Suppose method maxInt is defined with three int parameters x, y, and z, and it calls method max of the math class twice to calculate the largest values of x, y, z. Method main calls method maxInt, passing three actual arguments, num 20, 2 minus num, where num is a variable declared inside the method main and is initialized to value 2 before calling method maxInt. When this program executes, the Java command of JDK invokes the method main. Then the activation record of the main method is created and pushed into a stack. The activation record of a method call contains three pieces of information about the call, including the return address of the caller, the memory space of the formal parameters of the method, and the memory space for the local variables of the methods. The local variables are the variables declared inside the body of the method. So the return address is needed so that the call method knows how to return to its caller. So the activation record of method main contains the return address of the JDK's Java command because that's the caller of the main method. It also contains parameters args and the two local variables num and result. When the method call maxInt executes, its activation record is created and pushed on to stack on top of the activation record of method main. The activation record of maxInt contains the return address of the method main because method main calls maxInt. It also contains parameters x, y, z, with x receiving the value of variable num, which is 2, and y receiving value 20, and z receiving the value of 2 minus num, which is 2 minus 2 or 0. The activation record of maxInt also contains its local variables max underscore yz. In the execution of maxint, it first calls max the max method of the math class, which has two formal parameters, a and b, and no local variables. Then the activation record of the first call to math.max in the maxint method is created and pushed onto stack on top of the activation method of activation record of method maxint. In this call to math.max, the first parameter a receives the value of y, which is 20, and the second parameter of the max method receives the value of z, which is 0. When the first call to max finish, its activation record is popped off the method call stack. It returns control back to maxint and also returns value 20 back to maxint. The returned value 20 is then assigned to the local variable max underscore yz. Method maxint then calls the method math.max again, passing x and max underscore yz as arguments. Then the activation record of the second math.max call is created and pushed onto the stack on top of the existing activation record of maxint. In this activation record, parameter a of math.max receives value x, which is 2, and parameter b receives values of max underscore yz, which is 20. When the second call to math.max finishes, its activation record is popped and it returns control and value 20 back to maxint. Then maxint returns a value 20 to main. At this point, the call to maxint in the main method also finished and its activation record is popped off the stack. Note that when a method call's activation record is popped off the stack, all memory allocated for that method call is gone. So when method call maxint returns, all memory allocated for its formal parameters as yz, as well as its local variables max underscore yz, is gone. The only memory left after executing the call to maxint is those in the activation record of method main. That's all for this video. Thank you for watching, and I hope to see you again in my next video, which is part 2 of methods in Java.